All right. We're talking about a probably not a very hot topic, CDI. How many people have actually used CDI in anger? Okay. CDI. Okay, so a few of you. So you get the idea. It's a very rich kind of injection framework, right? For among other things, that's one part of it. But so the OSGi Alliance took on this venture to do CDI, and this is long in the works. As I mentioned in my other talk, I think it was Red Hat maybe in the mid 2000s to late 2000s, or late 2000s that did the first attempt to get a CDI specification in OSGi, and that didn't really go anywhere. And then I think there was another attempt later by David, and it's been tried multiple times. And I guess what happened more recently, maybe a year and a half ago, is I was tasked with a particular unrelated, not OSGi related kind of business requirement. And I'll come back to these in a minute. But so you may be asking yourself, why CDI in the first place? Why, when OSGi already has all of these other injection frameworks available? We started off with Blueprint, and then I think around the same time DES was evolving. I don't know specifically which one came before the other. Was Blueprint first or DS first and not rich enough? And then, so DS was first, but I suppose for a particular group of people at the time, they wanted a different kind of set of features that kind of precluded DS, because DS had very specific goals in mind. So I had some business requirements, and that's really what drove the specification for CDI, because there was no way that we were going to be able to deliver on what we were promising our customers without it. So that started off with that itch, and whenever a fairly complex specification in CDI starts up, I think that's really where the requirements come from, right? You have to have some need for it. So the other thing is that CDI has this thing that a Blueprint developer will always remind you of, that they would like to hide the concerns of the wiring of their application inside their bundle. They want to use encapsulation not only at the class level, like you would in a jar, but inside their bundle they want to be able to use a wiring mechanism to assemble the beans, let's say, or the classes or the objects inside the bundle, and hide that from the rest of the world. And Declarative Services doesn't really promote that, or doesn't, it's not that it's against that model, it's just that it's not oriented to that. It's just basically makes a different set of assumptions. And so you work mostly with services, which is OSGi's mechanism for communicating with the rest of the world. And so DS makes a bunch of trade-offs in order to be ultra light, ultra fast, and very, very OSGi native. The other thing is that we needed CDI for other reasons besides, so we had this business requirement, but we also have these developer requirements. When you have a large company, you can pretty much categorize the developers that you have at different levels. You ultimately want to build a business where every engineer that you have is a senior architect that can do everything on their own and has all the answers, right? But we all know that that's not the reality. The reality is that if you can get 1 or 2 or 3 really good architects that can do that kind of thing, they're a mentor for a whole slew of people who have much less experience. So you have to kind of build a model where people with less experience can be productive enough. And this kind of precludes a design for how you build your application. And extensibility is really important because you can provide features which are facades that a less intellectual developer can consume more easily and at least do something that is easier for them to accept. Which is why a lot of Java EE specifications became annotation-based as opposed to API-based, right? Let's take, for instance, transactional. If you wanted to, if a developer wanted to make a method that would do some business logic and be transactional, they didn't have to necessarily write any code. They could annotate a method, deploy their bean in a container, and someone else, far more intelligent, far more capable, takes care of the wrapping logic. At least that's the theory, right? So, but this model continues and grows on to more and more and more features, permissions, authorization models, logging, metrics analysis, and so on. You wouldn't want every single developer to have to be able to do all of those, take on all those challenges on their own. So you do something like write annotation sets that they can just easily annotate their code with. And then even reviewing the code is much easier. So CDI is important for those kinds of reasons. Now, but DS, right? I mean, we love DS at Liferay. The goal is not to build DS or build CDI, OSGi, and then throw away DS. So that is not even it's not going to be the intention of the OSGi Alliance. It's not the intention of Liferay, where we wanted to do this. So 99.9% of all Liferay bundles are DS. And the vast majority are going to remain that way forever. We're never going to switch them out of DS. And we will always take care to be a good supporter of DS. So we have a different mission for CDI. But DS, right? DS by design is ultra lightweight. And the DS annotations are merely a convenience to the developer because all of the work that the DS annotations is actually done at build time. So there's barely any processing of the component model in DS at runtime. It's super, super lightweight. And so what that means is that DS isn't an annotation processing engine. It knows nothing about doing this kind of thing. So CDI, although much more complex, it's basically an extensible annotation processing engine, which means that without modifying the original implementation, I can add some other extensibility to the environment that a developer can consume, and that just seamlessly integrates into the annotation processing, which is extremely powerful. On top of that, CDI allows complete internal private wiring. You can have 500 classes in your bundle. I don't recommend it, but you could. You can wire them together using inject inside your bundle, have a very complex structure, and none of that is exposed to the world. It's an internal concern. No one else needs to care. So, internal wiring, what does that look like in CDI? So we have a bean here. It's just a POJO, and it's annotated. The named is just one of the many annotations you can use on CDI beans, just as an example. And here we have a field which is annotated with @inject. And so when I run my application, the CDI container will hopefully find an implementation that implements this POJO type, and it will just wire it in. Very simple. Now, what we've added on in the CDI extension is the ability to take the same class and expose it as a service. I'm not going to go into thorough detail of the CDI stuff, but I just want to show like the crossover of where an application scoped bean in CDI is basically like a singleton inside your bundle, right? So this bean implementation class will be instantiated one time for the bundle, and then it's going to be published as a service. And what type is it going to use as a service? following the rules that are in the spec. I give a hint here, it's just going to publish it as the type. Probably not a good service design, but that's what it would do for convenience, right? If you had implements here, it would use the implements, and you could also specify in the service annotation and say which type specifically if you wanted to subset it, or if you wanted to include the implements with the class type so you could, do, sometimes that's a useful use case. The other thing that we do is that we add an @reference annotation, which is very much like a DS reference, where you can refer to an external OSGi service, or just any OSGi service. Doesn't have to be external, just any OSGi service. Type specific, and it will inject it for you. Now this, we can change it a little bit. Now in CDI, there are two special types of beans. There's many types of beans, but there's two special cases. The previous one is the application scope, which is kind of like your singleton. And then there's the dependent. The dependent is basically created on demand for any consumer that requires one. So in this case, I have a dependent service bean that's going to be published as a singleton into the registry, because the registry is only being informed that this is a singleton service, so it'll create it once. But if another bean or another set of beans inside the CDI application needed one of these, one would be created for every lookup, for every injection point. A new one would be created. Okay. Again, so we support bundle scope with dependent because it's created on demand for every requirement. We can say we want this dependent bean to be a bundle scope, so every bundle request, we basically map this to a service factory, and so every time the service factory is called, we create one of these using the CDI container. We ask it for the type, and it says, oh, that's dependent, I need to create a new one. It gives you the instance for that bundle, and so on and so on. And we can also do this with prototype scope. Again, because we map this to a prototype service factory. So when the prototype service factory says get, because the bean is dependent, the CDI container can say, oh yeah, you need a new instance. You need a new instance, you need a new instance. And then, because there's a life cycle for beans, the cleanup happens the same way that it would in let's say, in declarative services. When an unget happens, the whole bean structure is destroyed. Now, take into consideration that for every instance, you can have whatever object wiring graph that is necessary to define your model, right? So this can be as complex or as simple as possible. It can have a complex graph, or it can have a very simple graph. It doesn't matter. So references, what can you do with references? So this is an example where we're injecting a POJO service, but now we need to handle cardinality, because getting one service is just one single use case, right? Most of the time, OSGi services, there's a lot of different use cases for how you deal with services. Here we have a mandatory reference. So my CDI container will not start unless there's a service in the service registry of type POJO. And then my CDI container is going to fire up. And we can support optional. So we chose in the CDI spec to leverage the Java type system a little bit more than what DS did. Here we just literally use the optional type. So if you specify your reference as optional of some service type, it's going to behave exactly that way. Your CDI container is going to start up whether there's a POJO service or not. But it's still mandatory. So you're not going to get rewired. You're going to get destroyed and then recreated. But we also support the multiple cardinality. So if you have a list of POJO, we're going to give you a list of POJO when we have some to give you. And we can also support the at least one or at least n cardinality by using a qualifier, a minimum cardinality of n. So we have exactly the same cardinality options that we have in declarative services. And then how do you deal with greedy or reluctant? We have learned from not necessarily the mistakes, but things we didn't realize were necessary that we would have liked to do differently in declarative services. And when we discussed this in the expert group, it was heavily leaning towards, if we had to do it again, the default reference in declarative services would have been greedy by default as opposed to reluctant, because we find ourselves in, particularly in complex applications, realizing that, hey, we need to be able to modify these on the fly, and having to go back and refactor the code to include the dynamic policy on everything is problematic. So everything is greedy by default, but if you want to go back to reluctant, you can annotate your injection points with at reluctant. Yeah. Yeah, so a good point, David, good point. So greedy, so reluctant means that if a better service, and the qualification for better service is has a higher service ranking and is older, right? Is older and higher service ranking. If one of, or is that, what's the natural ordering, right? It's a higher. Yeah, that's what it is. Yeah, which is older. So basically, we just call that natural ordering and better by natural ordering. So if a better service happens to come along, and if you're reluctant, you're not going to get rewired with it. You'll never see that. You're going to live forever with the one you have. That's reluctant. Greedy is actively updating you with the best possible service. And how do we do dynamic? And in this case, dynamic mandatory. Well, CDI already has a concept of dynamic, and it's called provider. So we just wrap the reference with a provider of service type, and then we do a get. And every time we do a get, provider basically is a one-method interface, so it's get. You need to continuously call that get method in order to see what the state of the reference is. Yeah, this predates it, yeah. It could have been supplier in the end, when, yeah. So if you want to have a require or mandatory optional dynamic reference, you would have a optional wrapped in a provider. And so you'd have to go get pojo.get in order to check whether you have null or not. But at least it's based on the type system. And then multiple, same thing, provider of list. So get, do I have a list? Provider will always return a value, by the way. This is mandatory still. So if it's not satisfied, the get, you wouldn't even get here. You wouldn't even, the CDI container wouldn't be started up. So the provider.get will always return something. It could be an empty list, yes. Could be an empty list, but you're going to get a list. You're not just going to get a null. So, and then we move on to the next layer, right? So those are the references and the services that you can use. Most of what we've talked about so far is over on the blue, because I haven't explained or I haven't referenced the fact that this CDI integration fully implements a model for components just like DS has. But it's layered. It's layered because CDI always has what we call a container component, which is kind of like a host. It's a host part of the application that always exists. And then your actual dynamic components are children of the container component. So here we have an example where the container component is actually multiple beans, right? So you have, this is your traditional CDI application. So if you were to remove all of this part and take away all of your at service and at reference from this side, this is exactly what a CDI application today looks like. And you would code it in exactly the same way inside the CDI integration. The difference is that let's say you have a reference here that is, let's talk about the configuration admin, which is a required, a mandatory reference. I'll get to you in a second, okay? Or are you asking? Okay. So the configuration admin is a mandatory reference. So the CDI container won't start until config admin is available, but when config admin goes away, all of these beans are destroyed. Not only that, if there had been any components, all of these would be destroyed first, and then all of this would be destroyed. So this layer is more like a singleton. It behaves as one unit, which is not something you can get around in CDI because of the wiring model. It's essentially a singleton CDI container. But what CDI does allow is custom scopes, which are have a defined life cycle completely up to whatever the implementer decides, which was a good in for us to build on the DS type dynamic component model. We could create our own scope that lives on top but has a separate life cycle from the main application, main container component. So we have factory components which react to factory configuration instances. More factory configuration instances you create, the more factory components you get out of it. If there are none, you get none. Single component can live without configuration. It's optional by default. Or you can specify some policies against configuration, which I haven't shown, but just for brevity. Single components are just like your typical DS components. They react to their both of these react to their dependencies and configuration independent from the main application, so they come and go as necessary. Now, if this is empty, which is completely valid, now your bundle looks exactly like DS does, because you have single components and factory components. You're not predicated on having actually any beans in this part of the application. So when you did that, you'd have, let's say, 2 component classes inside of your CDI bundle. That's perfectly valid. And then it looks exactly like CDI, or exactly like DS. But if you were to look at the internal structure of the application, of the extension, of the CDI bundle and the CDI container inside, it would always be doing some work here to control some central state, and then the components live on top of that central state, which is the container component. Right? So we get some other cool things. We can inject an OSGi Logger. While we were doing it, we were saying, hey, we're adding this really nice logger integration with DS. Let's add it to CDI too. Let's not get behind the curve. Component properties. We could do these new component property types in DS where you can use an annotation, or actually this is more reminiscent of, what do we call it again in DS when you inject the activation types? Activation object, right? So this is mapping your component properties onto a type and then injecting it into your DS component. We have exactly the same model here. So I just say component properties on the injection type, and the component properties are going to be injected. Now if I'm in here, if I make that injection point from the container component, I get the container component properties. These will all see the same container component properties. But if I'm in the single component and I ask for to be injected with the component properties, I'm going to get the component properties associated with the single component. Same for the factory, and I'll get the component properties associated with the factory instance. Right? So we have, where is it? Lots more to talk about in the specification. I recommend taking a close look. I would appreciate any feedback that you all have. one of the things that I wanted to accomplish, one of the things we like to add more recently is some good code snippets in the spec as well. So, where's that? In the comment of the code. 5, yeah, that's a placeholder. It's just for the spec purposes. It's what you call iconology, or you're the one who suggested to do it. Anyway, what's that? Yeah, it's defined. It's defined here. See the container PID. It's a mapping of the container PID plus the component name. So there's a mapping. This is the other part that is interesting, is that every single reference, just like in declarative services, can be targeted to update its target filter, right? So, but that was more complicated to do inside the CDI environment. So we have a slightly trickier mode of namespacing the target filters, because you can have, they're qualified by component name and actually type, because you could specify, you can have multiple beans that live inside the same component that all refer to the same, that refer to the same service, but you want to individually target them, right? So here's an example of having a single component that requires 2 different configuration PIDs. You can have as many as you like, and they are ordered. So there's an ordering to how they are aggregated together when the component properties are actually visible to the component. Whoops, what did I do? On the page there, okay. Of course, and referring to a PID without the name just places the default, because every component has an implicit PID, just like you have in DS. The configuration PID of a DS component defaults to the component name. We have the same thing, and you need to be able to set the order in which you'd want that to be aggregated with the other PIDs. So you can just use PID with no name. Smashed together, right? Like when the component actually gets the configuration at the end, everything has been smashed together. Exactly, yeah. So there's multiple sources of configuration, of component properties, right? You start with just like DS, right? Yeah, you start with the annotations, which are the defaults. Exactly, yeah. Here we got a factory component. You can change the name of the component by using the CDI method of naming things, which is the named annotation. So if you want to customize the component name, you can do that. And here, yeah, that's just a component name. You can specify a policy individually per configuration PID, which you can't do in declarative services. So this is a slightly more richer use case here. So this PID com acme foo is actually required, whereas com gamma bar is not required.
The question there, when you have multiple PIDs in the factory, only one of them can be a factory configuration, right?
Exactly.
Because otherwise you have an ambient.
These, whenever you see the PID annotation, this is never a factory PID.
So you specify the name of the factory PID.
As the value of the factory component. So that way it's nicely isolated from, you always know which one is which. So component properties. Here's an example. Here's a description of targeting a reference injection point, so you can update the target filter. Here, the component name by default, or the field name actually, is HTTP, and so it's http.target, and then you put that in the properties in the component, wherever the component properties for a specific component. A minimum cardinality. Bean property types. So bean property types is the CDI integration specs version of component property types, where you can annotate, you can meta-annotate an annotation, which will then be coerced back or into component properties if it's on a component bean, or if it's on a reference, it'll be coerced into a target filter. Yeah, here's an example of that. So the props is a component property type with some default values, overriding the default values, and then when it's injected into the activate, which is just an injection point, method injection point, the props are cast automatically to the type, and you get the actual override. Those have to be annotations as well. Bean property types have to be annotations, but the activation object can be any type as long as the converter can convert it from the map of properties to the type that it's being coerced to. So here's the way that the bean property type mapping of method names to property names is done. It's exactly the same as in DS. We have some default component property types offered for CDI. We had to do new annotations for CDI because DS's component property types are class retention, which means they're not visible at runtime, but CDI is all runtime annotation processing, so we couldn't reuse or like make a more standard yet. Anyways, we hadn't figured out a way to kind of put that into the same set, so we duplicated some of them for CDI purposes. Here's the same coercion table that we have in DS. And here's just more example. Oh, I went through the services and everything in the references already, not in a lot of detail, but I think you get the idea. One thing that I wanted to mention, which I mentioned in the beginning of the talk, is the model for extensibility and how it's different than traditional CDI. Those are all the types. Actually, I'm going to use the menu here. Coercing, providing services. Relationship to CDI, portable extensions. Okay, so if you've ever used CDI, you know that CDI rarely is used on its own. It's most of the time used in conjunction with another set of annotations which are implemented using extensions, portable extensions specifically. So this is a model where CDI has an SPI, where the extensions can implement the SPI to enhance the processing of the types that are your CDI beans. But the problem is that CDI usually assumes that this is on a flat class space, right? That's using service loader to find the extensions and whatnot, but we didn't want to do that in OSGi because it would be really limited. We wanted to make sure that full dynamics were taken into consideration. So, but conveniently, the CDI SPI requires that all extensions implement at least one type, right? So we have this type. We just require the CDI extensions to be published as a service using that type. They have a requirements and capabilities model, which means that when your code uses, let's say, an annotation, the annotation will ideally, the annotation will be meta-annotated with the requires on the extension. That will cause basically a love triangle of class space consistency, and then the CDI extender will get the service on behalf of the CDI bundle, add the extension to the CDI container, and execute with it, and everything is, you know, everything is wonderful. Everyone's working together. Here's a funny story. You cannot. Okay, we're stopped, right? So one last detail. You cannot create a CDI extension using a CDI bean. So you would have to, one of the options you have is to use DS to create a CDI extension or you have to figure it out another way to register the extension, the service loader mediator or an activator. It's crazy. CDI the whole CDI engine everywhere has logic that just says, oh, it's an extension, blah. It doesn't want to get caught in the loop, so it just precludes any interaction with extensions. So it's really weird. You'd have to create a bean that uses the service registry calls directly to register an extension service, which would be uglier than probably using DS. Or just to use service loader mediator. Anyways, there's a lot in here. CDI is a big spec. Please read this spec. I think it's gonna work. Yeah, that's it. Thanks.